Okay, so if we're going to graph y equals 2 to the x, 2 is the base. You could graph y equals 3 to the x. 3 would be the base. So you want to come up with your parent table first. So for 2 to the x, I would pick -2, -1, 0, 1, and 2. 2 to the 0 power is 1. And this is going to be always the key point for all your exponentials. If I was doing y equals 3 to the x, and I picked the same x values, 0 for my exponent, 3 to the 0 is 1. So that shows you your key point for exponentials is always 0, 1. So I can plot 0, 1 as like my key point. And then if I do 2 to the first power, it's 2, 2 squared is 4, and these are always the reciprocals. So this one would be 3, 9, 1/3, 1/9. So I'm just going to graph this one here. So I go through 0, 1, then I go from 0, I go to the right 1. So from 0, I go to the right 1, and then I go up 2, like that. And then I go right 2, up 4, right 2, up 4. If I went left 1, I'd only go up a half from 0, so it's here. So you're kind of like going down a half. And you have to know that your asymptote for exponentials is the x-axis, so you just can kind of get close but never touch. So then if I had y equals 2 to these, let's say x minus 3, you use the same parent function, but instead of starting at 0, 1, you start 3 to the right. It's a horizontal shift. So instead of starting at 0, 1, I go 3 to the right, 1, 2, 3. And then I would use these as like my driving directions. I would go right 1, up 2 from here. This is my new starting point. I used my transformations based on the key point. So I'd go right 1, up 2, then I go right 2, up 4. And then this one I go left 1, and it's only a half. So my asymptote didn't change, so it's still at the x-axis. So I'm going closer and closer, and then this grows really big. So you're, just like we did with quadratics, you're going to use your key point to start, and then from your starting point, use your transformations to go left or right or up or down. That's it.